So for this question, we are finding the mass of similar solid. So mass fall under volume. So when we explore mass, right, we will still be doing it like volume ratio. Okay, so some of you might want to do it this way. You can write it as a mass ratio like this, M1 over M2. Sorry, this one is a cube. So the mass ratio is actually the same idea as volume ratio. So here we got two cubes. It doesn't look like cube. So a bigger one and a smaller one. So this is 4 centimeter, this is 10 centimeter. But for the mass, right, this one is 80 gram. This mass is unknown. It's bigger than 80. So this is the L1, this is the L2. So you assign your M1, M2, L1, L2, and then you match it into the formula. So it's 80 gram. That's the X. Okay, the ratio. So again, right, I will cube the ratio first before I go for the cross multiplication. So your calculator would have helped you to reduce, and then you cross multiply. So the mass you found will be in gram, same units. So volume ratio and mass ratio, they behave the same. So same thing, we're going to explore another shape, which is like a cone. So two similar cone we got. Okay, so maybe again, I'm going to draw out a smaller cone and a bigger cone. Okay, they gave us two volumes, so I'm going to write down the volume. So I usually will like to assign the volume first, or I can assign the area, whatever. So the radius of the larger cone is 14. So I can let this be a L2. So this is the L1. So I like to find the radius of the small cone. So again, I'm going to write out the ratio. So write out the formula, plug in whatever you have. So how do you proceed from there? You can cube the fraction, then you cross multiply. So for me, I think it's much easier if I cube roots. It'll be much easier if I cube roots. So if I cube roots, I will get a 6 over 7. Then I will cross multiply. I will get a 12 centimeter. So the base radius is 12 centimeter. Okay, I'm not so sure, but let me just do a double check that I didn't punch calculator wrongly. Yeah. Okay, 12 centimeter. Okay, the next one, we are supposed to find the ratio of the surface area. So when you want to find the ratio, no need to go and find the actual one because we are just trying to find the ratio. So no need to go and find the actual surface area. So that's, we don't need the actual one. We just want the ratio. So again, I can use the same formula. Okay, so no need to go and find the actual one. Just take the ratio that you have. So the ratio is, just now our length ratio is 6/7. So take your length ratio and square. So you'll get a 36/49. So you don't know the actual value, but eventually the area, the actual surface area will reduce to 36/49. So this is not the actual area, it's just a ratio. So there's no need for you to go and find the actual one. So in fact, okay, we will still have like this kind of real world context. So they show bucket, and then they already say that they are similar. So the question says that they are similar, and they gave us a base area. So read this question. So this base area is in the ratio of 7:10. So this is the common mistake. A lot of people couldn't interpret the 7:10. So is the 7:10 length ratio or area ratio? Okay, so this can be A1, 7 units, A2, 10 units. So this is the area ratio. Okay, so from the area ratio, so don't forget, okay, we got the formula. So we can play around with this formula. So you can put the formula side by side first. But you must be very sure that the 7:10 is actually area ratio. So for part 1, I'm supposed to find the circumference. So the base circumference. So this is C1 equal to 58. So I'm trying to find C2. So circumference fall under the length ratio. So if you want to, you don't want any confusion, you can stick to L1 and you can stick to L2. So how are you going to find the circumference of the big bucket? So we use the area ratio. So I'm going to use this one. So it's 7/10 is 58/L2. So how are you going to do that? Same thing. You can either square both sides. Okay, then you cross multiply. I mean, square the fraction and cross multiply. Or you can take a square root. Take a square root, multiply, and then you divide. So this is the real circumference because 58 is the real circumference of bucket X. So I need to multiply, I need to divide. So I'll get 69.3 centimeter. Okay, then part B, each bucket is going to be filled completely. So by the time the adults and the children reach their home, 20% split. So if 3.6 liter remain in bucket Y, so I would like to find the capacity of bucket X. Capacity means when it is 100% filled. Okay, so this 3.6 liters that is remaining here. So this 3.6 liters that's remaining in bucket Y. is actually 80%. So before I do any volume, okay, this is not volume 2 yet. I'm going to find the full volume. So I'm going to find the full capacity of bucket X, bucket Y. So it should be 3.6 liter divided by 80% times 100. So let me find the full capacity first. So the full capacity is 4.5 liters. So the 4.5 is the full capacity. So I'm going to compare the full capacity. So this is like my A2, my volume 2. So this is my volume 2. I would like to find my volume 1. So I should use the volume ratio. So V1 over 4.5. Take the length ratio. So just now, where is my length ratio? This was my length ratio. So this was my length ratio. So after I take square root, right, this is my length ratio. So from here, you multiply. So that is in liters. So this one will also be in liters. So it's around 3.76 liters for bucket X. So we twist around with the length ratio because the length ratio can enable us to get the volume ratio. It will also enable us to get the area ratio. So they are somewhat linked by the length ratio. So you just have to be very mindful about which is which. Otherwise, it's actually quite easy.